All right, so ions are atoms or groups of atoms that have a charge, and they have a charge because they've either lost or gained electrons. So instead of their protons being equal to their electrons, that's no longer true. And when we talk about groups of atoms, those are the polyatomic ions. So those are those ones that are at the bottom as far as the back of your periodic table. All right, so when an atom or molecule gains or loses electron, it goes from being neutral atom to being an ion. Cation, or some people say cation, have lost an electron, and now they have a positive charge because they're losing something negative. The way I remember is that I think of that T as a plus sign, and then that helps me remember that these are the positive ions. And this is what happens to metals. So for instance, magnesium right here is just a neutral atom, and magnesium is element number 12. So that means it has 12 protons and 12 electrons. And then to become more stable, it's going to lose 2 of those electrons. And that means now it only has 10 electrons, but it still has those 12 protons. So that's why it has a +2 charge. So if electrons are lost, and that's what metals do, then that becomes a positive ion. If electrons are gained, and that's what the nonmetals do, then they become a negative ion. And it'll be positive or negative to the amount of electrons they either gained or lost. So for instance, this magnesium lost 2, so it's positive, and then it's a 2 with the positive. So anions are what we see with nonmetals. Instead of a positive, they end up becoming negative because they've gained electrons. And once again, they're either gaining or losing electrons to become more stable. They want to get an octet. So when we start with our nonmetals, really around group 15, as far as their valence electrons go, they're pretty close to 8. So they would rather gain electrons. So they form what's called an anion, which has a negative charge. So nitrogen has 5 valence electrons because it's from group 15. So if it gains 3, then it'll have a full valence. So it goes from being neutral to being a -3 because it's gained 3 negative particles. Sometimes kids get a little bit confused, like if it seems like if you gain something that you should become positive, it seems like the math is kind of backwards. But remember, you're not just gaining or losing something neutral. You're gaining or losing something that is negative. So sometimes it kind of it helps to think about like on maybe a number line. So the difference between an atom and an ion, and how you know, is because an ion will have a superscript that would be a charge. So Na is plain old sodium. Straight off the periodic table, protons equal to electrons. And Na plus, that is the sodium ion. It can be written plus if there's no number behind a plus or minus, it's an assumed 1. If we look at a nonmetal, O is oxygen, where my protons are equal to my electrons, but O with a -2 is now the oxide. And you don't have to put ion, but you can put ion because it's gained 2 electrons. We talked about that earlier whenever we were counting protons, electrons, and neutrons. A metal, to change its name, you simply tack on the word ion. A non-metal, you have to change the ending to I. And once again, if you look at your ion sheet on the back, if you look at the negative ions, they've already have that name changed for you. So if that helps you out a little bit, look on the back. They already have changed everything to I on that. All right, so let's look at these. If you look at that group of 8, and put a check by everything that is an ion, whether it's positive ion or it's a negative ion. So which ones are going to be our ions? Oh, top row, right? Another question I get asked is like, this is oxide -2. If you put 2 minus, that's fine. I'm not getting that particular on you. That's not to say that you might not go to college and have a professor that is that particular, but for me, I'm okay either way. All right, so anions, let's put a circle around our anions. Anions, positive or negative? Negative. So we got a couple of those, right? Iodide and oxide. That ending was changed to "ide" because now they're ions. So my cations should be my positive. So we'll put a box around those. And then what I'm left with should be neutral elements. So did we have those all left over? Yeah, there's all my neutral elements where my protons are equal to my electrons. All right. So I've kind of said it a couple of times, but the reason that elements gain or lose electrons is they want to become more stable. They would like to have an octet, which is 8 valence electrons. And if they can do that and become more stable, then they can exist at a lower energy level. And everything in the universe, not just us on weekends or when it's this rainy kind of weather, but everything on the universe wants to exist at the lowest energy level possible. So that's why water is formed. Hydrogen and oxygen are more stable when they come together and form water than if they stayed separate, and they want to become more stable and at a lower energy level. So there is a reason why compounds are formed. Same thing with table salt, sodium chloride. Both of those, sodium, group 1, fluoride, a halogen, both very reactive, but they come together and they're very stable. So when an element wants to become an ion, it wants to become isoelectric with a noble gas. And isoelectric means same electron configuration or number. So group 18, that's our noble gases. Does anybody know how many valence electrons they have? 8, exactly. Remember groups 1 and 2, and you'll see some periodic tables will be numbered a little bit different. Sometimes you'll see 1A, and that'll be groups 1 and 2, and then they'll start with 13, but they'll call it 3A, 4A, so forth, and then they'll do the transitions as B. But most of our periodic tables are labeled just like the one that we see up here. So everything in group 1 has 1 valence electron, everything in group 2 has 2. And then we skip over starting with 13, we have to subtract 10 to figure out how many valence electrons they have. Because the most that they could have would be 8. So for instance, group 13, they can't have 13 valence electrons, they have 3. Now, for our noble gases, what was our exception? Which one doesn't have 8 valence electrons? Helium, but it's still stable, but it just doesn't happen to have, it's so small it can be stable with just 2. So when an element is losing or gaining electrons, it wants to do that. So now it's going to look like a noble gas. So if I look at magnesium, which is element number 12 on your periodic table, which one is the closest noble gas to it? And it can be before it or it can be after it. Neon, perfect, whoever said that. Neon. If you look at neon, it's element number 10. Magnesium is element number 12. So they're just 2 spaces apart. So neon is element number 10. So that means it has 10 electrons because it's neutral, it's electrons and protons. Magnesium is element number 12, so it has 12 electrons. So how many electrons does it need to give away to get to be isoelectric? It needs to get rid of those 2 electrons. When it does, then it'll go from being neutral to now having a +2 charge. And now instead of 12 electrons, now it has 10 electrons. It gets to look just like a noble gas. So I'm going to draw a Bohr model of magnesium. You don't have to draw this. So if we look at our Bohr model, magnesium, before it's an ion, it has 12. So it has 2 in my first one. Then my second energy level, it has 8, 3, 4, 5, 6, 7, 8. And then in the last one, its last energy level, so that would be its valence. It only has 2 electrons. Real far away from 8. And that's what is making it so reactive. If it can give away these 2, which it does, then it can fall down to a lower energy level. So that means it's giving away those electrons. So now what does it have? That has 8. It has its octet because it got rid of those 2 that were kind of causing the problem. So now it has a noble gas notation and now it's stable. So that's why they are doing that. All right, I think we probably have already answered some of these things along the way. So we said it needed to lose, said it needed to lose electrons. Yeah, we said that a couple of times. We just jumped ahead of ourselves. And we predicted and it was a +2. So now let's do one with the non-metal. All right, non-metal. So fluorine, what is its closest noble gas? Neon also. So fluorine has 9 protons, so it has 9 electrons. We already said that neon has 10 electrons. So what does fluorine have to do to become like a noble gas? It needs to gain 1 instead of losing. So it goes from 9 electrons to 10 electrons, and now it would have a -1 charge because it gained 1 electron. And I'm going to do the same thing. I'm going to draw its noble gas notation. You don't have to draw this. I'm not going to ask it on a quiz or test. So originally it had 9, so it had 2 here. And then on its next one, it had 7, 2, 3, 4, 5, 6. Is that correct? 7, yes. 7. So 7. And how many does it want? 8. And it has room for 1 electron to come in here, and it'll steal an electron, usually from a group 1 metal. And when it does that, it takes that valence from 7 to 8. So it goes from being very unstable to being very stable. So that's why it does that. So my non-metals, they're close enough to 8 electrons that they can take electrons. They're going to gain electrons. The metals are too far away from 8, so they have to lose the valence electrons that they have. All right, like I said, we probably have already answered some of these. We said fluorine is a non-metal. It needs to lose. That's not what it needs to do. It needs to, let's try that again. It needs to gain electrons to get to its valence. And I think the next slide, we already talked about 2. It says it's going to be a F1. All right, so the periodic table, it's really easy to predict what kind of electrons there are. So on this one, we're going to add, instead of these being 4A, let's add our 13, 14, 15, 16, 17. If you can kind of slide them in there. So on this page, we're going to talk about valence electrons. And then you'll see there's another slide that's just like this. So if I talk about valence electrons, Maybe, I don't know if you have a different color pencil, you can maybe write them in a different color. I'm gonna do mine in red. As far as valence electrons, everything in group 1 always has one valence electron. Remember, you probably have a red pen right in your pouch. Everything in group 2 has 2 valence electrons. When we come over to the other side, we have to start subtracting 10. So in group 13, those have 3 valence electrons. Group 14 have 4 valence electrons. Group 15 have 5, and then 6, and then 7. Why do you think that the noble gases aren't even listed on there? Yeah, because they're not, are they going to form ions? And that's what we're talking about? No. So like on your practice, when you get to one and it's a noble gas and they ask you what kind of ion that it's going to form, is it going to form one? Nope. So you'll just put that, no ions, because they're not going to form ions. They're already stable. What did I meant to write? Did I say a 2 and I wrote a 1? That's supposed to be a 2. Sorry, y'all. So that's how many valence electrons. The ones that have 1, 2, or 3 valence electrons are going to lose electrons. They are too far away to get to 8. And they are metals, okay? That's our metals. The one that has 4 valence electron, which is carbon's group, is a little tricky. They're right in the middle, so they tend to share electrons. And those will be covalent bonds. We'll talk about those a little later. The ones that have 5, 6, or 7 valence electrons, that's pretty close to 8. So these can gain electrons. They're going to try to gain enough electrons to fill up that valence. So with that being said, if you go to your next slide, everybody got what they did on that one? Which is just kind of a duplicate. But now instead of talking about valence electrons, we'll talk about what kind of ions they form. So everything in group 1, they have 1 valence electron. They want to get rid of it. So they're going to all form a +1 ion. Group 2 have 2 valence electrons. They want to get rid of those. So they form a +2. So it's not written in, but group 13 have 3 valence electrons. So what do you think they're going to form? What kind of ion? They're going to be a +3. They're still a metal. And the reason there's only aluminum is because out of group 13, aluminum is the main one that you'll see that is reactive and will form ionic bonds. Carbon's group, we're going to leave it alone because it tends to share. But now we're going to start on our other side where we have 5, 6, or 7. So if I have 5 valence electrons, they want to gain 3 to get to 8, so they become a -3. My oxygen group has 6 valence electrons. They want to gain 2 more, so they become -2. And my halogens, my most reactive nonmetals, they have 7. They want to gain 1. And then they become a -1 ion. So just looking at that, which elements do you think might react with each other to form a compound? Which ones kind of seem like they go together? Group 1 that wants to get rid of 1 electron would go with what group that wants to? The halogens, right? Because they want to gain 1. So they kind of fit together. So you have a lot of compounds that are formed between group 1 and the halogens. These want to get rid of 2 electrons. This oxygen group wants to gain 2 electrons. So you'll have a lot of compounds out of those. Yes, and then they come together and they cancel each other out, and now it's neutral. And those are called ionic compounds. And we'll get to that a little bit later. But yes, that's exactly what they do. They become neutral. All righty. So just kind of a statement. I think this just sums it up. Metals lose electrons and become cations, and nonmetals gain electrons and become anions. And so then if we wanted to write this symbol for a sodium ion, because that's what one of the things you're going to be doing on your practice, what would be the first thing that I did? Look for sodium. So what's my symbol for plain old sodium? Na. Perfect. It's in group 1. So when it becomes an ion, what kind of ion is it going to become? A +1. So that would be my sodium ion. Same thing, if you just put a plus, you're good. If you happen to put a 1 and then your plus, all of that works for me. Okay. All right. So on your practice, that's what you're doing. And let's see if I can, there we go. All right. So I want to just look at a couple of these, and then I want to come back and look at some transition metals on this practice. All right, so let's look at number 2. So number 2 is a halogen bromine. So its element symbol is going to be Br. Since it's a non-metal, I can't just tack on the word ion. I have to actually change it to bromide. And like I said, if you get stuck on how to change the ending, look on the back of your green sheet. It can kind of be like a cheat sheet. So my ion formula, I would start with my symbol Br. And since it's in group 17, what kind of ion would it form? -1. Perfect. And then magnesium, I start the same way. It's just this plain old symbol. It's a metal, so I just need to keep the same name and tack on ion. And then as ion formula, I start with my symbol, and then I look, and it's in group 2 plus, perfect, +2. So if you look on the does anybody have any questions on that so far? Well, except it's 1 and 2, it's very easy, but remember on there, you're going to have to subtract the 10. And then you have to make a switch at 14. So 13, yes, it has 3, so it's going to become a +3. But at 14, make a switch. And so for the ones that have 5, 6, or 7, you need to start adding electrons. Okay, so then instead of positive, they'll become negative of how many electrons you need to add. Yes, like bromine, exactly. Like oxygen. Oxygen would be O. I would have to change it to oxide. It is in group 16, so that means it has 6 valence electrons. So what's it going to become? A -2. Remember, it is adding 2 electrons, but think of it as adding 2 negative things, so it becomes negative. Okay, if you can flip real quick, I know the bell is going to ring. I just wanted to show you a couple of these that are these that have the number in parentheses. Those are your transition metals, and they can have more than 1 charge. So the only way you're going to know what kind of charge they're going to have is if you're told, okay? So on this one, we have iron. So I forgot what I'm writing on my first column. The symbol? Okay. Fe, and then it would just become an iron ion. And then it's almost like this is a cheat sheet. I don't even have to look at my periodic table. The fact that it has a Roman numeral 3 tells me it's going to become a +3. That Roman numeral tells you what the charge is, and it will always be positive because they're always metals. So like this one, 10, SN. So that's the 10 ion. So I would use my SN, and then it has a Roman numeral of 2. So it would be what? +2. I'm sorry?